Okay, so the last presentation for today's session is looking forward, or is the AI a tool in the image processing, or it can be a threat for the science? I have some slides, but I will have also the opportunity to speak with you and to see your point of view. You can tell me after several minutes, but let's see and let's start. Because we have the AI in one hand and we are scientists in the second. We have the both, actually. Let's see the point of view of the AI and what is the task of the scientist. Let's say for the scientist, it's easy. The first and the essential part, we need to do a research, right? After the research, we need to conduct it in the ethical way, trying to discover some innovation. Hopefully, that will be a problem solving, and after that, we can publish the results, right? So we need to follow some rules in our field. Almost the same thing is if we use an AI framework or different algorithms. What is the logic of the AI? So first of all, we need to create the infrastructure. We need to find our data. We need to find which type of algorithm we can implement. We saw it today. We can find what is the possibility of our machine to accomplish the task. Is it enough powerful, or we can change it to do our stuff? Is it necessary after that to proceed the data? Once we have it, we can strive to computer vision or try to make some object detection, for example, segmentation. We saw it today. If you have the segmentation, probably you can detect the object, or you can apply different algorithms to detect it. After that, you can continue to the cognitive layer, which means you will try to understand what actually you have perceived till now. You have the data you perceived. So you done the research, and you need to do it in the correct way. So you need to pass through the data, the perception, and now to understand it. Probably not only to understand it, but try to discover something into the data. This layer can be related to, for example, knowledge. Knowledge that can be given from us to the computer, or knowledge that the AI will try to find itself. After that is the decision. Probably you can solve the problem, the AI will try to solve it also. If you tell to the AI that you need to solve this particular problem, okay? And probably you can try to do it in an expert system. If you are an expert in the field, so you can make it an expert also in the field and to do the task in the automatic way. And after that, you will go to the application layer, where you will use the knowledge that you have done, and you will tell to another one, for example, like a publication, you can try to use the knowledge and to spread it over the other applications. What is this is the application layer, and where you can apply your knowledge. For example, you can take the knowledge from school. Not probably, but it's sure that you will have at least several information about how to proceed a signal or some math knowledge, and you will apply it in another way. So to calculate not only how much money you will have during the week, but you can compute how many pixels you have into your image, what is the content, etc., etc. So to proceed the information. When we talk about artificial intelligence, it is common error to tell to all the algorithms that it's AI, that it's, for example, okay, you will have one algorithm and you can think that it's AI. No, the AI is a family of different types of algorithms, and also it's the primary algorithms, the decision making. It's, is it true, is it false, is it white, is it black? You have it, you doesn't have it. Okay, this is the decision making. And you need to calculate what is the probability to be or not to be. Like Hamlet, but a little bit not like that. To not be, what is the probability? The probability will be calculated from 0 to 1. Again, 0 will give you 0%, 1 will give you 100% of the information, of the probability. What is the probability to being object 1 or object 2? So this is the primary knowledge. After that are the machine learning technique, like the cameos that we saw today, the clustering algorithm. After that, those are the neural networks. The neural network, we will see it in any minute. So those are the different architectures which were developed around 1950. They start to be connected, and the first one was the Boltzmann machine. And the recent one is deep learning, which is based on neural networks, but in more deep architecture, which means that if you have, for example, one entry, this is your data, you have a black box, you have output. So here, for the neural network, the first one, the easy part, will be to work with some, let's say, pixels, only the pixel, or some measurements, or I don't know what, or a vector. And you will proceed it like, okay, I will have this information. I have names here, I have the date, I have the affiliation. If I need to pass through the information, okay, I counted 10 or 12 people or 20 people, that's enough. I will finish. So you won't enter into the deep knowledge, let's say like that. Also, what is important here, it's probably to achieve for one particular task. If you use machine learning technique, you can achieve, for example, accuracy of 70%. But you want to make it better. So you will try to use some neural network technique. Okay, you can achieve, for example, 85% accuracy. But using on the same data that you gave to the machine learning and neural network, you can give it to the deep learning. Those are the heaviest architecture. You see? You can achieve, for example, 95. It depends, of course. And to strive for excellence, which means to 99% or 98%, you need to touch the data.
What do you need to touch it?
That means to look at the feature, to find new data, to clean your data. Because during the process, you can add some pictures that are not related to the content. Because when you take the pictures, for example, you look on a star, and you will try to find this particular star or any other star. Your telescope is focused on the stars, but something can happen. For example, falling star, and you will add the falling star into your database.
Yes.
And you will achieve different result
Yeah.
in the course. So you need to clean a little bit your data.
Okay.
After that, what are the type of the learning? Well, we as a human beings and the same part of the AI, we have the possibility to give us some teachers which will help us to learn. So we will have a teacher who will show us which is right, which is wrong, what is it, what is not, etc. etc. It's called supervised learning, where we will train our black box, our neural network or deep learning black box with labeled data. Which means you will give them an image and you will tell them, okay, this is your original image, but the content is class 1, class 2, class 3. For the second image, it belongs to the class 1, class 2, class 3. The third one, class 1, class 2, class 3. Okay? This is a supervised learning. And you have two tasks: classification or regression. Classification, you will have, for example, if you train your model with 3 classes, you can find only 3 classes, and you will classify the data. If it's present, it's related to class 1, class 2, or class 3 if you have 3. The regression is if you have the data, you will strive to find, let's say, the hyperparameter that will divide your data, and okay, this is the point, this is the value that you need for your particular data. After that, you have unsupervised learning. Imagine that you need to go to sub-exam. This exam is image processing, and you doesn't have any teacher. And you receive different images with different content. How you proceed it as human being? So probably each of us have different technique to learn from our known data. In this case, you can search for: is there any pattern? Is there any color, different texture? Is there any particular form? I don't know, something that can to help you to describe the information. Here, it's named unsupervised learning, and we will train the data with data which is not labeled. Here we have the label. For the unsupervised learning, we doesn't have the label. And we will proceed clustering. We will try to find a clusters, group of data that can be divided itself. And Last one is reinforcement learning. It's a model that we took into account the error previously done, like the monkeys. Is it okay? I will touch it. I doesn't know. Oh, it's hot. Okay, next time I will don't touch it. Probably. Oh no, I touched. Okay, in the third time I won't touch it. Okay, it's the same principle. And here we saw the galaxy, and we can find another galaxy. If we doesn't know which one the content, we doesn't know the content of the two images, what we can see. Okay, I have something like circle, and I have something like, I don't know, probably triangle and another triangle. Can I find this same pattern here? Yes, it's pretty much a triangle, and yes, there is something circle in the middle between them. So yes, okay, they are the same. What are the difference? Here the circle is smaller than this one. And those triangles are bigger than those two. Which means that there is different size, or they are different states of this particular object. What I can see? I can see that there are something like it's bright than the other, right? There is something bright and there is something bright also. There is something bright and another something bright. And the position of them are almost the same to the circle in the same center. So you can learn from the data and from the information that is not obviously presented. But from where it came? It came from the biological neuron. This is our neuron, and of course, this is the representation of the artificial neuron, or how scientists try to recreate the biological neuron to the mathematical explanation of the same function. You have enter, different number of inputs, and each enter can be represented as images or different measurements, and you will add it one by one, and you will add it with some weight. The first one will have weight 1, the second will have the second weight, etc. etc. You proceed all those inputs through the sum. So you will see the first one, the second, the third one, and the ending one. And you will sum all the information that you take into from the entrance, and you will take it with a bias. After that, because this is so the same biological part is represented by the formula of the sum of all the entrants multiplied by the weights plus the bias. After that, you need to activate this process, and you will do it by activation function. This activation function you can choose from 1 to 3. There are different activation function, and in the end you will have an output that will be, for example, if it's a classification task, you will have what is the possibility to be from class 1, class 2, and class 3, etc. The learning process then is the same. You will have your data, and after that you need to proceed it somehow. We saw today different types of proceedings of the data: image preprocessing, After that, we need to structure them into some database. We can try to learn the algorithm using our data, or we can apply some different outputs from different algorithms that will try to explain me the content that we have. And after that, we can have a candidate model. Probably we will find some good accuracy, but we will try to find the best model to get better results. That's why we will iterate till, let's say, several epochs. And after that, we will try to take the golden model and to find the application. This is the process of the learning process, of course, of the algorithm. And now, what is the use of the AI in the image processing? We can mention several of them. The first one is the automation. We will try to minimize the requirement of the manual investigation or how many hours we will need to proceed the data. Next part is improving the accuracy by, for example, using a deep learning model. After that, we can proceed with object detection and recognition, or to enhance and restore images, semantic understanding. We can create also new images with data augmentation. We can envision, we can search and optimize the data, and we can do a real-time processing. Yes, those tasks are also related, without the automation, to the human process. Yes, of course, if we can compare both our work, doing it by hand, will take us, for example, 1 hour. For the algorithm, it will take 1 minute. The accuracy, we can have some errors, let's say 5% of errors. The automatic algorithm can give you 6% of errors. Which one will be better? The time or the accuracy? It depends on the
Situation.
tasks. And now the question was, is it an opportunity and or a threat? The first I can ask you, and after that, how do you feel? Is it really a risk for us to be replaced by the AI, or it can help us to our work? How do you think?
Both.
Okay, why the both?
Because for sure some tasks that are done by people will be automated from the artificial intelligence.
Okay.
That's why some jobs will be lost.
Yes,
But
that's
new will come because, let's say, somebody has to supervise the artificial intelligence, and there will be certain people for it.
no, the AI doesn't need this time.
It's need regulation.
It's not done yet, but probably that will be the self configuration and the person won't be included. We cannot.
It's easy to tell yet, but for sure it will something like the industrial revolution, something like that. It will bring more automation. It will increase the standard of living.
Hope for the standard of living
Yes,
to
for
live
sure.
forever. I doesn't want it.
Not forever, but to work less and to have more time for yourself.
Okay. You?
I think it will be an opportunity for the people who know how to use AI and a threat for those who don't.
Yes.
Or
Yes.
rather for the people who learn and the people who don't learn, respectively.
Okay. Another suggestion? I already received several projects from students written by the AI in the field of the telecommunication, and the topic was architecture, particular architecture, and the application it in audiovisual system. And I received this project. You will find the first door. There is no door everywhere. The second door, the third door, the house. In the artificial intelligence, there is no houses, there are no windows, doors, etc. So he gave the whole architecture, the name architecture. The AI related it to the architecture of the house, and he get the information without understanding it. Okay, so it's a real threat. Any other suggestions? Or we can ask ChatGPT. Okay, I will ask him. I will copy paste.
We cannot see.
Okay. Is it visible now? This is ChatGPT.
Yeah.
Okay, I copy paste the title of the session and I will edit. And I will wait. I forgot to tell him hi. Okay. Let's see, he thinks that he's the both of them. Okay. Wow, he wrote a lot. Okay, let's read the summary. The AI in image processing can be valuable tool for scientists, offering increased efficiency and accuracy. Okay. However, it also poses challenge in terms of interpretability, bias, and potential job You read it. Okay. So scientists need to carefully consider the application of AI, address ethical concerns, and ensure the human expertise remain an integral part of the image processing workup. Okay, perfect, thank you. But yesterday he told me something different. Yesterday he think that the scientists cannot be changed.
What cannot be changed?
We cannot change, it's not a threat for the scientists. Today he tell me something different.
He read more papers.
Okay, so thank you ChatGPT. And now I will tell you, is it visible? For me, actually the answer is in the data. If you give wrong data to the AI, you will achieve wrong results. If you obtain wrong results, you will be wrong, right? If you don't use the AI or the algorithms related to the AI, you can have the data and you can be wrong also, because probably you can do some mistake, right? But if you have the data and you know that it's right, and you receive some false information from the algorithm, who will be, let's say, it's not a good position, the algorithm or the scientist, who will be wrong? The algorithm or the scientist? If
The
you are,
algorithm.
and who will do the algorithm? The
The
scientist.
scientist.
So again, it's related to the data. And yeah, thank you for your participation. If you have any questions, it's time to ask me, or we can continue the conversation with the ChatGPT, but I don't think that it will be really nice. And yeah,
Do you think because in the new Samsung phone, they already use artificial intelligence for processing images of the camera.
okay.
So do you think the also Sony the new camera also has in the processing artificial intelligence? Do you think that it will be in the future everywhere?
The AI is everywhere now, actually. If you want to open your phone, no matter what is the type of the phone, iPhone or phone like that, if you want to open it, what are the possibilities to open it?
Fingerprints, codes.
Okay. You will have a sensor. You will have a sensor, and to open it, now it's closed, right? I will add my finger, and yeah, it's open because I tell him, okay, you need to find if my fingerprint is the same that I learn you to open the phone. It's the AI.
But isn't that programming?
It's programmed. The AI is in your phone
Okay, but
already.
okay, then what is the difference between programming and artificial intelligence? That
Programming.
yeah, because this is if I have a fingerprint on the finger sensor, I open the unlock the
Yes,
phone.
and somebody
Just coding of the programming language.
yes, you code your algorithm.
Yes.
You learn it with different fingerprints to have the knowledge how to open a phone with different fingerprint. If you want to learn your algorithm to find the fingerprint, you need to learn the algorithm to find it with different data. Okay?
Okay.
You're not so agree with me?
It looks like advanced programming technique.
Yes.
Not like some conscious that
Yes.
decides which is right and
Yes,
wrong.
yes. It's high level programming. It's not something that, oh, AI, yes, you can think alone. No,
Yeah.
no.
Okay.
No, don't worry. Other questions?